All right, 5.1 is where we're moving on to next. I will put the link to the entire packet on, let's see, it would have been yesterday's date, which would have been the 26th, I think, something like that. And if you can't, you're not here to get a packet, you can at least start the work, all right? You can print off a page or two and only do that at a time until you get here and you get the entire packet. I'm not going to cover Module 4, it's piecewise functions. I won't dive into that as to why. What we discussed yesterday in class. Yesterday was just defining some terms, which I'm going to do now. And basically it talks about geometry is everywhere in the world. We're moving away from quadratic functions and moving to geometric figures. Geometry is everywhere. The table that you would sit at in class, if you're at a desk at home, the table at home, everything, geometry is everywhere. And it says one of the things about geometric figures is that our world is filled with them. For instance, the bathroom mirror is a perfect square. The tiles on the floor are perfect squares. Plus the edges of these shapes are straight lines or segments, which are pieces of lines that are theoretically aligned. And theoretically a line goes forever. It goes infinitely in each direction. Even though like this table may stop, okay, it might have edges, but theoretically the lines that make up the edges of this table could continue infinitely in each direction. And it says, look around you. Try and think of, and I challenge you to pause and try and think of at least one or two triangles, trapezoids, parallelograms, cubes, or perpendicular lines in this world. Now, before you do that, I'm going to talk about what these are, just to redefine them, because it's been many years, some of you, since you've seen this. Obviously, a triangle has three sides. A trapezoid can have two different types of shapes. It can look like this, or it could look like this, right? That's a trapezoid. The idea behind a trapezoid is it has one set of parallel lines. So I'll just write one set. Then we go on to a parallelogram. Parallelogram will have two sets of parallel lines. So this most notably is a rectangle. Yes, it is. But a rectangle is a parallelogram. It is a certain type of parallelogram, specific because it has four right angles. It still meets the definition of two sets of parallel sides. Like down here, this is a parallelogram. To know for sure that it's a parallelogram, I have to know that it has two sets of parallel sides, or I have to know that opposite angles are congruent. Knowing that, yes, it's a parallelogram. A cube is like a dice, okay? The thing about a cube is all sides have to be the same length, okay? That's a cube. And then perpendicular lines, this is what we had to discuss. The biggest topic that came up in class is, intersecting lines. Well, here are two intersecting lines. Which one's perpendicular? One of them is perpendicular, one of them is not. In geometry, we get into specifics. Specifics, you have to. You just have to. Because this doesn't identify perpendicular lines. This does. Why? Because these lines form a 90-degree angle. All right? Just like over here. The edges, the edge and the base, the right side and the base are perpendicular. All right? Over here, we would have the left side and base be perpendicular. Nothing perpendicular, nothing perpendicular, nothing perpendicular. If we went with a right triangle, perpendicular, the base and the left side, perpendicular. Now, take a minute, pause, and see if you can come up and identify some of those things. All right, so hopefully you've actually taken the time to do that, because it's not complicated. In class we had a lot of good conversations about things. The pendants on my wall, the ones that say California Angels, Oregon Ducks, Fighting Illini, you know those ones that look like this, a pendant. Those are triangles. Trapezoid, I didn't get any, a few students did. There was the paper towel dispenser, I have a Kleenex box that I modified, that was a trapezoid. The side of a storage container that I have is a trapezoid. Those were some good ones. Parallelograms, the tissue box on the back table, some storage boxes that I have over there with pencils and other things in it. Those are parallelograms. Cubes, die, delivery boxes could be perpendicular lines. We got the seam here with the rail of the whiteboard. I got the top side of the door and the sides of the door jamb. Those are perpendicular lines. The table legs and the top are perpendicular. Lots of different things that we talked about. Okay. The next thing it wants me to do, question number 2, and take the piece of paper if you printed this out. If not, the piece of paper that you're using to put this stuff down on, and go ahead and fold it. It wants you to fold it in half. So you're going to go ahead and you're going to do the best you can to fold it like that and make a seam. All right, so I'm going to give you a minute and give you about 10 more seconds to do that. Shouldn't take you too long. Didn't take me. All right, now that you folded it, open it back up, and it wants to know what shape is formed. It didn't say shapes, okay? It's not talking about these. What shape is formed? What happened? A lot of you are missing this, and this is where it's not that you are. It's just we need to learn the language of geometry. We need to see things differently. The shape is a line. A line is a shape, yes. According to geometry, a line is a shape. So it says, open the paper and examine the shape you made. Is it a line? Yes. Write that down. Will it always be a line? The answer is yes. It's always going to be a line. I'm never going to fold this and open it up and it not be a line. Now, the other thing you need to do is justify your thinking. This is where you get to write down why. What do you think? No right or wrong answer. Why do you think it's always going to be a line? Pause while you do that. Question number 3. Look at the wall where it meets the ceiling. How would you describe the intersection of the wall and the ceiling? Well, in my classroom, we talked about that yesterday. It's got a wall and it's got a ceiling. And that looks like this. Okay? And most people say, oh, 90-degree angle, perpendicular. Well, yeah, but it's talking about something different. Not all walls and ceilings are like this. What if you have something in your home where the wall and the ceiling is like this? It's called a vaulted ceiling, not a 90-degree angle. This angle right here that's formed is not 90 degrees. It's not talking about that. What it's talking about is it's talking about whether you have a 90-degree angle or you have a vaulted ceiling, what is formed? It's a line. If you look at the edge there, in any point in my room, any point in your bedroom, your house, your living room, kitchen, wherever, it's a line. Now, some other things we need to look at and define. It says, imagine folding a circle exactly in half. So now we're going to define some things about a circle. So we take a circle, we cut it in half, and we got a couple other things here, and we're going to be done. Okay. So I'm looking at I'm not going to write the entire paragraph. It talks about line, then it goes on. It talks about a straight angle. Sorry if I didn't get all that in there. Yes, I know my writing's bad, but I'm trying to hurry because I don't want to make this very long. And then we have radius, and it goes on and talks about straight angle again, and then we have question. It's actually question number 4, not 14. I meant to cross off the 1 and didn't. All right. So here's what we have. All right. You have some paragraphs over here, and it says, the fold is called the diameter of the circle. Well, let's go back and discuss what is a diameter. You have plenty of room on your paper right here. You're going to write the word diameter over here on the right-hand side, and you're just going to draw a line with an arrow pointing to BC, diameter BC. And you notate capital B, capital C with the segment above it. Segments are parts of lines, so we can notate that. The difference between a segment and a line is simply this. Here's a line. Notice it has arrows. Here's a segment. Since it's a circle and it's bound by B and C, all right, I just wrote the segment. So the diameter goes from one side of the circle all the way to the other through the center of the circle. The center of the circle would be A. It's called a line segment with a length, but it also is a special kind of angle called a straight angle. So over here in your paragraph, you're going to, I boxed straight angle, and I drew a arrow to line, okay? So it's a straight angle. We're talking more about angles than we are circles, but we're identifying a few other things as well. A straight angle is a line, right? In order to see the angle, think of the center of the circle. That center, that point is the vertex of an angle. So the center here, if we have angles, okay, actually BAC is an angle. A is the vertex, it's the center of the circle, it's notated by a point. Either side of the vertex is a radius of the circle. So here we have radius, so I'm going to box that, and I'm going to draw an arrow to radius, and I'm going to say BA or CA. Either of these are radii, okay, or a radius of a circle. What's the difference? A radius is half the diameter. So a radius is from the center to the side, diameter is all the way from side to side, but it has to go through the center. Whenever you draw two radii of a circle, you make an angle. When the two radii extend in exactly opposite directions and share a common side, an endpoint, the center, they make a line called a straight angle. So BAC is a straight angle. Question 4. How many degrees do you think are in a straight angle? Going from B all the way over to C, right? If you said 180 degrees, you are correct. Right? So that takes care of our definitions for today. If you flip over on the back, if two angles share a vertex together, they make a straight angle. And you have 3 examples of that. There's one here, and then you have a perpendicular where it talks about, at least it appears to be perpendicular. They don't say exactly that it's 90 degrees, right? But here are 3 different variations of what a linear pair would be. What defines a linear pair? A linear pair defines 2 angles that add up to be 180 degrees. And you have a couple other picture examples there. The work that we did in class that students are supposed to bring back today is draw at least 2 diagrams of a real-life linear pair. I don't want you to draw, I just want you to name them. Right? I'm saving you the pain of drawing. Just name, think out in the real world, name 2 sets of linear pair angles in real life. And that's it. That's all we did for 5.1.